Bismillahirrahmanirrahim. Assalamu alaikum. I am Hassan Zada. Today we will discuss lecture number 3 of data analysis in SPSS, that is checking reliability of a scale and treatment of reverse coded item. In the previous two lectures we have discussed data entry in SPSS in lecture 1, and in lecture 2 we have discussed descriptive statistics and frequency distribution. And now we will discuss checking reliability of a scale and treatment of reverse coded item. So what is scale reliability? The reliability of a scale indicates that how free it is from the random error. The scale should be reliable and it should be free from the error. There are two frequently techniques that can be used to check the scale reliability. One is retest reliability technique, and the second is to check internal consistency of a scale. In this lecture we will use the second one, the internal consistency. Internal consistency is used to check the scale reliability. So what is actually internal consistency? Internal consistency can be defined as degree to which the items that make up the scale are measuring the same underlying attributes. For example, in this tutorial, we will discuss self-esteem as an example, the scale of self-esteem. The scale of self-esteem have 10 questions, 10 items, that is from self-esteem 1 to self-esteem 10. So here the internal consistency means that all the 10 questions, all the 10 items that make up the scale of the self-esteem are measuring the same underlying construct, the same phenomena, which is the self-esteem or not. If all of the 10 items are measuring the self-esteem, then we can say that the scale for self-esteem is reliable. If the 10 items are not measuring the self-esteem, then we will say that the scale of the self-esteem is not reliable. So how it will be reliable? If there is a strong relationship among all of the 10 items of the self-esteem and there is a positive relation, then we will say that the scale is reliable and it is measuring the same construct that is the self-esteem. If there is weak inter-item correlation, if the relationship between the item is weak or negative inter-item correlation, then we will say that there is a weak scale reliability or the scale is not reliable at all. Cron-Batch alpha is used to measure the internal consistency of a scale. The value of Cron-Batch alpha provides an indication of the average correlation among all of the items that make up the scale. For example, if the value of the Cron-Batch alpha is 0.90, it means that there is 90% relationship among the 10 items of the self-esteem. The Cron-Batch alpha value ranges from 0 to 1. 0 indicates that there is no correlation among the items of the scale. 1 means there is 100% correlation. There is perfect correlation, perfect positive correlation between items of the scale, with a higher value indicating the greater reliability. If the value of Cron-Batch alpha is higher, it means there is strong inter-item correlation and there is greater reliability of the scale. If the Cron-Batch alpha is low, less than 50% or 50 or even less than 60.60, it means that there is low inter-item correlation and there is the scale is not reliable. One thing we should note, and which is very important, Before measuring the scale reliability or before measuring the reliability of a scale, you should check that all the negatively worded item mean reverse coded questions in your scale have been reversed. First, we will reverse all of the negatively worded item all or reverse coded question. Then, then we will measure the reliability of the scale. If we will not reverse all of the reverse coded question, then we will find a very low or incorrect Cron-Batch alpha value. Incorrect means that sometime the value of Cron-Batch alpha will be minus 0.05, minus 0.5, minus 0.6. In this exercise, in the scale of the self-esteem, item number 3, item number 5, self-esteem 5, item 7, self-esteem 7, item 9, and self-esteem 10. These 5 items are negatively worded items, or in other words, these are reverse coded questions. So now we will check the reliability of a scale. There are 10 questions that make the scale of self-esteem from question self-esteem 1 to self-esteem 10, and the self-esteem is measured on 4-point scale where 1 mean low self-esteem, 2 mean higher self-esteem, 3 mean more higher self-esteem, and 4 mean the highest self-esteem. So 4 is the highest self-esteem value and 1 is the lowest self-esteem value. Here 4 mean highest self-esteem, 3, 4, 4. These indicate the value for self-esteem. There are 436 observations in this data sheet. 436 observations. It means that we have collected data from 436 individuals and there is no missing value in this scale. So how we will check the scale reliability? We will click on the analyze, then scale, then we will click the reliability analysis. And in the reliability analysis, we will select all the items that are on the left side of the box and we will shift it to the item box. And in the scale label, we will write the name of the scale. The name of the scale is self-esteem. Self-esteem. Then we will click on statistics. In statistics, there are 4 boxes. First box is descriptive score. In descriptive score box, we will click the item, scale if item deleted. In the enter item box, we will check on the correlation. In the summary box, we will click on the correlation and then we will click on continue. And at the end, we will click on OK. Now these are the results of reliability. This table shows the results of reliability. Self-esteem scale is the self-esteem crash processing summary. Here the 436 indicates the total number of observation excluded 0. It means that there is no missing item. This is the reliability statistics. Here we will check the number of items, that there are 10 number of items that make up the scale of reliability. This is the Cron-Batch alpha value. The value of Cron-Batch alpha is minus 0.053, which is very poor, and it violates the assumption of reliability model. This value is negative due to a negative average covariance among the items. It means that the relationship between the 10 items that make up the scale of reliability is negative. Therefore, This violates the reliability model assumption. You may want to check item coding. We will check that is there any reverse coded question or not, and we know that we have 5 reverse coded questions. So it may be very poor value because the desirable value is zero point 0.7. The value of zero point 0.7, Cronbach alpha value of zero point 0.7 is acceptable. However, above zero point 0.8 is preferable. So this is not preferable. At least it should be 0.7. 0.7 is acceptable and more than 0.7 is preferable. Then we will come here the item statistic. These indicate the mean. Mean indicate that this is the mean of the first question, the first item out of 4. Out of 4, the mean value is 4.67. Means its mean is self-esteem, higher value for self-esteem. Here the question for 3, the mean value is 1.38. It means low self-esteem. So it just indicates the mean value of each item. This is the most important table, inter-item correlation matrix. Here we see that the negative sign, all of these item correlation should be positive and its value should be high, and the average value of inter-item correlation is actually the value of the Cronbach alpha. So here we see most of the negative sign. It means that there is something wrong with the questions. If we look to the questions self-esteem 1, self-esteem 2, self-esteem 3 up to self-esteem 10, there is negative sign with question 3, question 5, question 7, question 9, question 10, and it is because all these items are reverse coded and we need to reverse it. We need to correct it before we check the reliability of the scale. Where the summary item statistics, the mean value is minus 0.004, whereas the mean value, the benchmark for the mean value is that 0.2 to 0.4. It should be between 0.2 to 0.4, whereas this shows a value of minus 0.004. It means that the inter-item correlation, mean inter-item correlation is very low. So first of all, we will go back and we will correct the reverse coded question. So how we will? I called in the slide that we called it treatment of the reverse coded item. So first we will correct all the reverse coded questions. Question number 3, question number 5, question number 7, question number 9 and question number 10 are the reverse coded questions. So first of all we will make it correct. So what are the treatment? First we will calculate the mean value. First we will calculate the mean value for all of the 436 observation. For example, the mean value for the first row will be that we will sum all the values of the 10 items and then we will divide it by 10, because average is always equal to the sum of observation divided by number of observation. So the average value of the first row will be the sum of the observation in the first row divided by number of observation in the first row, and the number of observation are 10. But SPSS provide a command by which we can calculate the mean for all of the 436 observation. So what is the command? Click on transpose, then compute variable, and here in the target variable write the name of the variable on which you will calculate the mean value. So I am writing self-esteem. Self-esteem without number, it will be the mean value, while this is 1 indicate it is question number 1, 2 indicate question 2, 3 indicate this is question 3 of the self-esteem scale. SEST mean, it is the mean value. Then we will, in the functional group, we will click on the statistical, and in statistical then we will double click on the mean. When we double click on the mean, the numeric expression will show the mean. We will remove the question marks from here, and then we will shift all of the question one by one with comma between every question. Double click on question 1, it will shift to numeric expression, then put comma, click on question 2, shift it to expression, numeric expression, then question 3, comma, question 4, comma, shift question 5, comma, shift question 6, comma, shift question 7, comma, shift question 8, comma, shift question 9, comma, and shift question 10. Keep in mind that there should be comma after each question. If by mistake you will put a dot, then SPSS will not run the command. Click on OK. And this is at the end of the scale, at the end of question 10, after it, the self-esteem, these are the mean value. Now we can correct the, we will correct the 5 questions, question 3, question 5, question 7, 9 and 10. How we will correct it? Go to transpose and compute variable, reset it. We are first in the target variable I am putting r. R means that it is the reverse. I am reversing the first question, that is question 3. R self-esteem 3. Self-esteem 3. Then in the numeric box I will write 5 because our scale was of 4 points, from 1 with lowest self-esteem and 4 indicate the highest self-esteem. So if your scale is of 4 points, you will write 5 minus this variable. If you are using Likert scale of 5 Likert points, then you will write 6 and you will subtract the reverse coded question. You will click on OK, and the SPSS will show this is the reverse. We have corrected this question. We have corrected this question, and then further we will use this question, reverse self-esteem, instead of question 3, self-esteem. Then one by one we will correct the rest of the question 5, question 7, question 9, question 10. Then click on compute, transform compute variable, and here we will correct question 5, write 5, and here instead of 3 write 5. It means that we have shifted the self-esteem 5 to this numerical expression. Click on OK. This is a reverse self-esteem 5 which is corrected. Then again click question 7, 5 minus self-esteem question 7. This is question 7. Click on OK. This is, oh, we have not written 7. Clear it, and we will calculate it once again. Transform self-esteem, we will write it here 7. OK. Then question number 9, we will write 9 and here 9. OK. Then the last question, that is question 10, reverse coded question 10, and write here 10. 10 means that we have shifted this question to numeric expression. click on OK. Now these are the scale, but the SPSS shows that it is on nominal scale. From here we will check that it is a scale. And we will also put the decimal to 0. Just to make the window look better. Now these are the reverse. We have corrected these 5 questions. Again we will calculate the reliability. Analyze, go to scale, scale reliability, reset. We will shift question 1 to question 2, but not question 3 because it is reverse coded question and we have corrected. We will shift the corrected self-esteem 3, then question 4 and reverse coded question 5, question 6, reverse coded question 7, question 8 and reverse coded question 9 and question 10. Write here, write the name of the scale, that is self esteem. Enter item statistics, descriptives, click item scale, scale if item deleted. In the enter item, click correlation. In summaries, click on correlation. Click continue and click OK. Now these are the result of the self-esteem. Now look to the value of Cron-Batch alpha. Now it is 0.85. It means that which is greater than 0.7. It means that it is most desirable. And now if we look to the inter-item correlation, all of the negative values are converted into positive. So there is no negative value. There is no negative inter-item correlation. It means that there is positive correlation and the average value of the inter-item correlation is 0.85. It means that now the scale is reliable and we can use it further. Summary of item statistics. Sometimes we are using scale which have very low number of items. For example, some scale may have 5 number of questions. If the scale which have low number of questions or small number of questions, normally its Cron-Batch alpha value is very low. In that case, we will use the mean value of inter-item correlation. If the Cron-Batch alpha value is 0.6 or low and the mean value is greater or equal to 0.2 and it is greater than 0.2, then we will say that the scale is reliable. The scale is reliable. And these are the corrected item correlation. We will look for these values. If the Cron-Batch alpha value is very low, sometimes very low, then we will remove the lowest value from this column, the corrected item correlation, to make the better. For example, our Cron-Batch alpha value is 0.854 and 0.854. If we remove this question, then its Cron-Batch alpha value will be 0.846. If we remove this question, then its Cron-Batch alpha will be 0.845. But the value of Cron-Batch alpha is higher than all of these values. Then we don't have any need to remove any questions. And the theory says that we cannot remove any questions. because it will be this will be useful if you are developing a scale. But if you are not using, but if you are using a established scale, validated, which is a valid scale. Removal of item means if you remove any item from here, it means that you will not compare your results with other studies, because other study will have used all of the items, 10 items, and if you are using 9 items by removing any question, then you will not be able to compare your results with other studies. Thank you very much. This all from my side on scale reliability. Thank you very much.